Hi everybody, this is Ganga Raju, and here today I'm going to explain one more problem on Fourier series. One more problem related to finding Fourier series of a function in the given interval. Here the function is in this problem find Fourier series of f of x equals to x minus x square in the interval minus pi less than x less than pi. Here the interval is minus pi to pi, and here in the previous problem I was explained in the interval 0 to 2 pi. Here I am taking one more another problem which is related to the interval minus pi to pi, and the function is f of x equals to x minus x square, and here the solution is. And before moving on to this solution of this problem, we should have idea on the formulas of Fourier series. Fourier series. And now here these are the formulas. F of the formula for f of Fourier series of f of x equals to a naught by 2 plus sigma n equals to 1 to infinity into a n cos n x plus sigma n equals to 1 to infinity b n sin n x. And here after writing this formula we should find a naught, a n, b n, three constant values, and these are the formulas. And we should have idea on these four values: sin n pi equals to 0, sin 2n pi equals to 0, cos n pi equals to minus 1 whole power n, cos 2n pi equals to 1. And here you will have maximum sin 2n pi and cos 2n pi formulas in the interval 0 to 2 pi, and in the interval minus pi to pi you should remember these two: sin n pi equals to 0, cos n pi equals to minus 1 whole power n. Now let me take that problem, which is this. And here f of x equals solution I am going to give. Given f of x equals to x minus x square, interval is minus pi to pi. And now first write down the formula. Fourier series of f of x is given by f of x equals to a naught by 2 plus sigma n equals to 1 to infinity into a n cos n x plus sigma n equals to 1 to infinity b n sin n x. Let us take that one as 1. Here main thing is we should find a naught value, a n value, b n value, and we have to substitute again in this formula. And now f of x equals to x minus x square, don't forget that, and the interval is minus pi to pi. And now here first I am writing formulas for a naught, a n, b n. Those are the three values we have to find. A naught formula is 1 by pi into the interval is minus pi to pi, integral minus pi to pi f of x dx. A n equals to 1 by pi into integral minus pi to pi f of x into cos n x dx. Bn equals to 1 by pi into 1 by pi into, don't forget to write this term, integral minus pi to pi f of x into sin n x dx. In an show cos, in bn show sin. And now first I am going to find a naught. Consider a naught equals to, this is the formula, 1 by pi into integral minus pi to pi f of x dx. That is equals to 1 by pi into integral minus pi to pi, given function is x minus x square dx. 1 by pi into, find the integration of for these two terms. X integration is x square by 2 minus x square integration is x cube by 3. After completion of integration, write down the limits minus pi to pi. And now two terms are there. First in these two terms upper limit pi minus, next in those two terms in the place of x lower limit minus pi we have to substitute. And now that is equals to 1 by pi into, in the place of x pi, pi square by 2 minus in the place of x pi, pi cube by 3. That means I have substituted upper limit pi in these two terms. Now before moving on to lower limit, in middle we will have minus. And now in the place of x minus pi whole square means again pi square minus whole square plus pi 2 minus you have, but in the place of x while substituting minus pi whole cube means minus will be out, therefore minus into minus plus, and here pi cube by 3. And now put the brackets because we have minus. And now here what will we have? Solve this. 1 by pi into pi square by 2 minus pi cube by 3, substitute with minus pi square by 2 minus into plus minus pi cube by 3. This one cancel. Minus pi cube by 3 minus pi cube by 3 minus 2 pi cube by 3. Pi and pi cube cancel. What will we have? Pi square minus 2 pi square by 3. This is a naught. Next I'm going to find an. This is the an. And now next, write down the formula. An equals to 1 by pi into integral minus pi 2 pi f of x into cos nx dx. And now that is equals to integral minus pi to pi. What is f of x? X minus x square cos nx dx. And here this is a polynomial algebraic function. Therefore, this is algebraic function, this is trigonometric function. In annihilate, a comes first. Therefore, algebraic function is first function, trigonometric function is second function. Clearly I have written here. That is equals to 1 by pi into, continue the integration. If the first function is algebraic function, I have given a procedure. The procedure is first function into, in one step you can complete using this procedure. This procedure will be applicable only if first function is a algebraic function. And here first term, this is the first term, this is the second term. First term x minus x square into second term integration. Here don't do first term differentiation here, directly write down first term. Second term cos nx integration sin nx by nx differentiation n. And now treat this one as first term, this one as second term. And now after here this total terms sign will be plus, after plus we will have minus. This is the procedure. And now this is the first term, this is the second term. And now first term differentiation, second term integration. And now after finding this is the first term, this is the second term. After minus sign will be plus, first term differentiation, second term integration. I will explain why I am not writing fourth term. And now first term into second term integration is this. Now this is the first term, this is the second term, minus plus, after plus minus, first term differentiation. What is that? 1 x differentiation 1 minus x square differentiation 2x, and then sin nx by n integration, and 1 by n is constant, sin nx integration minus cos nx by n. N into n, what will you have? N square. And now this is the first term, this is the second term. After minus you will have plus. First term differentiation, second term integration. What is first term differentiation? 1 differentiation 0 minus 2x differentiation minus 2 into 1 minus 2. And second term differentiation. And now what is that? Minus you will have by 1 by n square you will have cos nx integration. Integration. Cos nx integration is sin nx by n into n square n cube. This is the second term integration. And now after plus I am not writing next term because next term is 0. Why? Because after plus what will have? Minus. This is the first term, this is second term. First term minus 2 differentiation 0. 0 into anything? 0. That's why I'm terminating here. That is the completion of integration. And here after completion of integration, write down the limits minus pi to pi. And now here complete integration. Now main thing is substituting in these three terms in the place of x pi, and then minus in the place of x lower limit minus pi. And now here first directly I am substituting in the place of x in these three terms. I am substituting now pi. And now here in the place of x pi minus pi square. Here why I am writing pi minus pi square? Because in the place of x if you write pi, sin and pi is 0, 0 when 0, 0 into anything 0, we have 0. And then minus into minus plus. And the signs are important whether it is plus or minus. Minus into minus plus. In the place of x 2 pi, 1 minus 2 pi. And here already I solved this minus. Therefore in the place of x pi, cos n pi is minus 1 whole power n by n square. Second term completed. Third term minus into minus plus I have written, plus into plus I have written. Why I am writing? Because 0, because if you write pi here in the place of x, sin n pi is 0. 0 by n cube 0, 0 into anything 0. This is 0 we have. And then these three terms are related to lower limit minus pi. I'm going to start lower limit. And now here before starting lower limit minus you should have. And here what we have? Plus into minus I have written. Here in the place why I am writing 0 here? Because substitute in the place of x minus pi, sin minus n pi, sin of minus n pi minus sin n pi, minus will be out, sin of minus theta minus sin theta. Therefore minus will be out, minus sin n pi you will have, minus sin n pi is 0, 0 into anything 0. Therefore we have 0 here. And next signs, minus into minus plus, plus into for lower limit we will have another minus, plus into minus, minus, this is a minus, and in the place of x pi, 1 minus, in the place of x minus pi, minus into minus we will have 1 plus 2 pi, and here already I solved this minus, cos n into, in the place of x minus pi, cos of minus n pi, cos of minus n pi, again cos n pi, cos n pi means minus 1 whole power n by n square, and here what we have by n square, this is the term you have, and then minus into minus plus, and here for lower limit another minus, plus into minus, minus. Why I am writing 0? Because sin n into minus pi minus sin n pi, sin n pi is 0, 0 into anything 0, this is 0, therefore this is the solution we have. Solve this again, and here multiply 1 by pi into 0 have taken off 1 into this one, minus 2 pi into minus 1 whole power n by n square, minus 2 pi minus 1 by n square. Next, minus 1 into minus here written 1 into minus 1 whole power n by n square, minus 1 whole power n by n square, minus, minus into plus minus I have written 2 pi into minus 1 whole power n by n square I have written, and this one cancel, and here minus 2 pi minus 1 whole power n by n square, minus 2 pi minus 1 whole power n by n square, how many? Minus 4, minus 4 pi minus 1 whole power n by n square, pi cancel, what will have? Minus 4 into minus 1 whole power n by n square, this is an. And now after finding an, I am going to start finding bn. As I told before in the previous problem, if you are able to find an, some similarities are there between finding bn and an. Previously in an, here we have cos, now I am having sin, that is the only difference. 1 by pi into integral minus pi to pi, f of x into sin nx dx is the formula for bn. And now I am continuing solving this. 1 by pi into integral minus pi to pi, what is f of x? X minus x square into sin nx dx, and now that is equals to 1 by pi into, since x minus x square is algebraic, that is the first function, sin nx is trigonometric, that is the second function. By following the previous procedure related to having first related to that procedure, in that procedure we have first function, if the first function is algebraic we can use this procedure, and now first function is this, second function is this, first function into x minus x square into second function integration minus cos n x by n, after plus what will have? Minus, treat this one as first term, this one as second term. First term differentiation, what is the first term? X minus x square, x differentiation 1, minus x square differentiation is minus 2x. Second term integration, minus we have cos nx integration sin nx by n into n square, after plus minus, after minus what will have? Plus, this the, treat this one as first term, treat this one as second term. One first term differentiation, second term integration. First term 1 differentiation 0, minus 2x differentiation minus 2, second term integration minus by n square is constant, sin nx integration is cos nx by n into n square by n cube, minus into minus, what do we have? Sin nx integration is minus cos nx, what do we have? Minus into minus plus, complete integration, and here we don't have any another term, because if you can continue after plus what will have? Minus, first term, this is first term, this is second term, we will treat first term differentiation, what is that? 0 into anything 0, therefore next term will be 0, that's why I have terminated here. After completion of this, write down the limits minus pi to pi, and now as usual as before, in the place of x pi in these three terms upper limit, and then minus, in the place of x we should replace lower limit minus pi, and now, and here in the place of x pi, here this is pi, in the place of x pi square, and here since we have minus I have multiplied with, actually this is pi minus pi square, since I have multiplied with minus, that changed as minus pi square minus pi, in the place of x already I solved this, I have multiplied this, therefore we don't have any minus here, and now in the place of x pi cos n pi minus 1 whole power n by n, and here why I am writing 0? Because in the place of x if you replace sin n pi, sin n pi will be 0, 0 into anything 0, that's why I written minus into minus plus 0, and then plus into minus, in the place of x if you replace pi, cos n pi is minus 1 whole power n, minus 2 into minus 1 whole power n by n cube I have written. These three are related to upper limit pi, and now here for before moving on to lower limit you should have minus here, but here for this term you will have another minus into minus plus, and in the place of x minus pi I have written, in the place of x minus pi whole square again pi square minus pi square, and here minus already I have solved, cos n into in the place of x minus pi lower limit now, cos of minus n pi again cos n pi is minus 1 whole power n by n, and here minus into minus plus y m minus into minus plus, and here we have another minus related to lower limit, that's why here minus into minus plus, but for lower limit another minus you have, another minus you will have, therefore here minus into minus plus, plus into minus minus you have. I am writing 0 because in the place of x minus pi sin of minus n pi again minus sin n pi, minus sin n pi means 0, therefore 0 and anything 0, and here we have this term because here we have minus, for lower limit another minus you will have, minus into minus, minus into that minus plus, plus this the plus 2 into cos of in the place of x minus pi, cos of minus n pi again cos n pi, which is minus 1 whole power n by n cube. Now here, and this term will cancel, what will we have, and multiply these two terms with this term, pi square into this minus pi into this one and this one cancel, minus pi into this the term, minus pi square into this the term, this one and this one cancel, minus minus both are same, minus 2 pi into minus 1 whole power n by n, pi cancel, what will you have, bn equals to minus 2 into pi cancel, minus 2 into minus 1 whole power n by n. This is bn, and now I have found an value, this is an value, and this is the bn value, and what we have, this is e naught value, substitute these in this one, what will we get, we get this f of x equals to, from 1 f of x equals to, what is f of x minus x square, that is equals to a naught by 2, what is a naught, minus 2 pi square by 3 by 2 plus sigma n equals to 1 to infinity, what is an, this is an into cos n x plus sigma n equals to 1 to infinity, this is bn into sin n x, and this is the Fourier series of the given function x minus x square. I'm continuing this, x minus x square equals to 2 into 3 6 2 by 6 1 by 3, therefore what do we have, minus pi square by 3, if we solve that, minus sigma n, and here plus into minus minus we have sigma n equals to 1 to infinity, what we have remaining, 4 into minus 1 whole power n by n square into cos n x plus, and here plus into minus minus we have sigma n equals to 1 to infinity 2 into minus 1 whole power n by n into sin n x. This is the required Fourier series of the given function x minus x square, and here if you want to expand you can expand this expansion is useful when you are having deduction, and I will take one more problem related to deduction and I will explain that problem. Thank you. This is Ganga Raju.